I hope you're all enjoying your snow day and staying warm. Today's lecture, which we'll be doing here online, will be focused on organizing data. So taking data and putting it in a format that you can get a story from it at a glance. Before I get into the nitty-gritty of how to do that, however, I'm going to start by complaining about some more statistics. So this is an article that I came across in the news a couple years ago saying that a New Jersey city, this was Hoboken, had achieved 0 traffic deaths in 4 years. So good for Hoboken. When I clicked through the article though, I saw a statistic that stuck out to me as being kind of fishy. So the article led with the statement that traffic fatalities had been on the rise for the past 16 years. Now, if you know anything about traffic fatalities, which I don't know why you would, but I had been reading a book about this at the time, I had known that for the most part, traffic and roads have been getting safer and safer and safer over many of the past several decades. So when I saw the statistic, it immediately stuck out to me as being a little bit odd. Is it possible that we've reversed this decades-long trend and the roads are getting less safe? And it's more dangerous and getting increasingly more dangerous, and that this has been happening for the past 16 years. So sort of with this question in mind, is it possible that this decades-long trend has reversed? I clicked that next link to see what was going on. The first thing I discovered was that there was an error in this article. So our article here says that traffic fatalities have been on the rise for the past 16 years. This implies that traffic fatalities have been doing this, right? We started down here and we ended up here. But this statement, which is what they're actually citing here, says something different. It says that traffic fatalities have reached a 16-year high. What this means is that we started at some higher point, we went down for a while, and then we came up and we reached that 16-year high again. So first thing off the bat, we've got an error here, and this is a statistic that has been misrepresented. Dug a little bit further. So we've reached a 16-year high. That still implies that traffic fatalities are going up. What's going on here? Why are the roads getting less safe? Or are they? So I dug up some statistics regarding motor vehicle crash deaths over the past 50 years or so. And what this graph shows are the total deaths and the deaths per 100,000 people. And what I have marked off here is this 16-year period that the article is referring to. So what we can notice here if we take a look at this graph is that the statement in the article is correct, right? So if we look at our total number of deaths, we started around here about 2005, and then by 2022, when the article was written, we've got a little bit more of an uptick here that's not shown on the graph. We're back to roughly the total number of deaths that we were at in 2005. But this isn't the entire story either, because if we look at the total number of deaths, we see this pretty clear U-shape. But if we look at the number of deaths per 100,000 people, we see a bit of a different story. And so that black line reflects a rate rather than a total number. And this is important because there are more people living in the US now than there were 16 years ago or 16 years before this article. So the total number of deaths would be expected to go up with more people, even if the roads stayed exactly as safe as they were before. But what we see when we look at the rate is that we're still at a much lower rate of traffic fatalities than we were 15 or 16 years ago, or now 20 years ago from today. So if we look at this graph, we've already got a bit of a different story. Yes, we've hit a 16-year high in terms of the total number, but that total number is misleading because more people in the US means that the same number of traffic fatalities corresponds to a lower rate of traffic deaths. In other words, your chances of actually getting in an accident are lower than they were. And then I dug even further because I'm a strange sort of person like that. And this is a graph of traffic fatalities over the past 100+ years. So basically since cars were invented and put on the roads. And once again, I've got this 16-year period marked off. So we can see again, we've got this U shape here reflecting 16-year high in traffic fatalities. But if we look at the overall rate of deaths over the last 100 years or so, we've got an even clearer story in which roads are getting safer and safer and safer. So our blue line here is this rate per 100,000 population, where over the past 100 years, the population has gone up considerably, so we would expect traffic fatalities to go up with it. But instead what we see is that basically, since cars became pretty common on the roads, we've seen a little wiggling and wobbling, but for the most part, the rate of traffic fatalities has gone down and down and down and down. And it would be much better to be on the roads in 2020, right, than in 1960 when we've got this pretty high rate per 100,000 people. But that's not even the full story. And here's where we really want to think about what we're measuring, what's a whole number, what's a rate, and then when we think about rates also, what is this baseline we're thinking about? So we've got changes in population, but is everybody driving, and how much is everybody driving? These are things that can affect our statistics as well. So I've got one more graph to show you guys, and to really, really complete my complaint here about that statistic and that sort of misleading use of it in the article. Here's our 16-year period preceding the article, and what we can see here is a graph where we're looking at the rate of traffic fatalities per vehicle miles driven. So that's how many people die on the road compared to how many miles are being driven in cars, as well as how many people die on the road compared to how many cars there are on the road. Because not only are there many more people in the US than there used to be, there are also more cars, and people are driving more than they used to be, especially if we look kind of into the further reaches back in this graph. And what we see here, if we compare the rate of fatalities to these measures that are much more relevant to actual safety on the road, so how likely are you to get in an accident if you're driving, how likely to get in an accident are you if you have a car, we can see a really clear story in which our roads have gotten safer and safer and safer. And if we start back in 1920 here, we can see that since cars were invented, your chances of getting into an accident per the number of miles you drive, or per the number of cars there are in the US, have gone down and down and down and down and down. And we do still have this slight U-shaped thing going on over here, but as you can see, it's basically a flat line. So if we're thinking about safety in terms of miles driven, in terms of cars on the road, not only has there been essentially no increase at all over the past 16 years, the roads are far safer now than they have ever been in the history of cars. And if we focus on just the total number here, this U shape, we really miss that point. And I like to highlight this example, partly because I like to complain about statistics, but also because I genuinely think it's important for news outlets to be accurate when they're describing things in terms of risk and safety. And if I hadn't been the strange person that I am and dug into all of this, I might have walked away from that article thinking that, man, the roads are getting less and less safe. This is really concerning. We'd better be doing something about this, when in reality, we're in basically the safest period of driving we've ever been. And further, while traffic fatalities probably isn't much of a passion for any of you, we also see this sort of reporting when it comes to all sorts of numbers and all sorts of rates. So the next time you see a news article reporting on a change in crime rates, check to see what that denominator is. Are we looking at a whole number? Are we looking at a rate? And then if so, what are we actually counting here? Because these things matter, and these things can completely change your sense of what the risks are, which way the country is going, and really what's going on here. So that's the end of my complaining about statistics for right now, and we're now going to head into the part of the lecture where I talk about how you guys can create some statistics to get a start on organizing data yourselves. And I'm going to start by showing you some of the class data. We saw this last time. As we can see, it's a big old jumble of numbers. We talked in the last lecture about how to interpret this, and you could go line by line and pick out some responses for different students in the class who took the survey. But overall, it just looks like a big jumble of numbers. So our main goal for today and our main goal in this video is going to take data that looks like this and turn it into something where we can understand something useful about it at a quick glance. And overall, the process of doing so is what we call descriptive statistics. With descriptive statistics, and it's kind of in the name, the word describe is in there, but we're trying to organize, summarize, and describe data, and again, to put it into a format where you can take something away from it at a glance. It's important to note that descriptive statistics are limited to the data that you can actually see. In other words, we're usually focusing on a sample and not a population when we calculate descriptive statistics. This is in contrast to some statistics we'll be calculating later in the semester, where we'll be using samples to learn about bigger populations than we can actually have access to. But with descriptive statistics, what we're doing in this first unit and what we're doing this week, we're focused only on describing the data that we actually have in front of us. And we're going to start off our descriptive statistics with something called a frequency table. A frequency table is probably the simplest type of descriptive statistic, simple because it requires no calculations. We're only going to be counting some things up. And what frequency tables show us is the number of times that different observations appear in our data. our focus is going to be on general patterns and tendencies. We just want to put that data on the spreadsheet into a format where we can understand patterns and tendencies for different variables at a glance. Frequency tables can be created for any type of variable, meaning variables at nominal, ordinal, interval, or ratio levels of measurement. No restrictions on the type of variable for which we can create a frequency table. What frequency tables show us, most importantly, is the frequencies of our observations, where frequency refers to the number of times that each observation appears in our data. And for any given variable, we're going to see the following elements in a frequency table. The first thing a frequency table will include is a list of the observations that are present in a dataset. For example, in the class survey, I asked you whether you support or oppose the death penalty. So the observations present in the dataset are support the death penalty and oppose the death penalty. There were no other answers you could have given, so there are no other observations that I could find in that class data for that particular variable. The next thing that I would want to include would be the frequency with which each of those observations appears. So how many people said they support the death penalty? That's my frequency for death penalty support. How many people said they oppose the death penalty? That's my frequency for death penalty opposition. The final element that I would typically include in a frequency table is the total number of observations. In this case, that would be the total number of people who answered the question about death penalty support.